Hey guys, so this is a video that's going to review slope fields and differential equations from AB Calc, and that's going to help us with our upcoming sections in Chapter 6. So I'm just going to review how to do these things. If you want to try them on your own first, because you remember how, that's great. You can pause and play as you feel comfortable with this material. Just do what you need to do to understand it and review it. So what we're going to do is we're going to practice graphing slope fields, which are super easy. What I like to do is I like to make a chart for my x, y, and my m, my slope, so dy over dx. And I just like to start plugging in some numbers, and so I'm going to say when x is -1 and when y is 1, what is my slope? So I'm looking at when x is -1 and when y is 1. Right here at this point, what's my slope going to look like? And so if I plug in -1 and for x and plug in 1 in for y, I'm going to get 2. So my slope is 2. Well, a slope of 2 should be somewhat steep, like that. Okay, so I'm going to do that for the dot above it as well. When x is -1 and when y is 2, what's my slope? So again, I'm plugging in -1 for x, plugging in 2 for y. I'm going to get a less steep slope because those 2's are going to cancel out. So now I'm getting a slope of 1. So it should be, it's still going to be positive, but not as steep. So let's look at some other values. Maybe I love dealing with zeros because normally you're going to either get, you're going to get a zero slope or you're going to get undefined, and those are easy to draw. So let's look at when x is 0. Well, when x is 0, it doesn't matter what y is, we're going to get out 0. So regardless of what y is, it doesn't matter, any number, okay, I'm going to get out a slope of 0. So this is my favorite part. Drawing a bunch of these. It's kind of satisfying to fill out all those different spaces. And let's look at when y is 0. So regardless of what number I have here, if I'm dividing by 0, I'm going to get undefined. So I'm going to draw that here. So that's kind of fun too. Okay, so hopefully you get the point. What I'm going to do is pause the video and let you fill out the rest of the graph, and then we'll come back together for part A. So here's the rest of my graph filled out. Kind of pretty. There's a lot. It's very symmetric. I've got my slope of +2, -2, +1, -1, and so on down here. So I just find that very satisfying, very pretty. Part B, that's all we're doing for part A, it's just graphing. For part B, what we want to do is start looking at a specific point. So we want to look at when the slope, dy over dx, is at the point 1, -1. That's what was given to us here. And we're going to use that to approximate what 1.1 is. So what I'm going to start by doing is just plugging in this point into my original, my slope. So I've got -2 times 1 over -1. That gives us 2. Chances are you probably already had it from over here. Anyway, if you're making a table like I do. Once I have my slope, I'm going to go ahead and write a tangent line, an equation. So I'm going to do y minus -1, so it's plus. My slope is 2, and then x minus 1. So I'm just using this coordinate point, this slope, to write the equation of a tangent line, just like we've been doing. I'm going to clean that up really quick, get y by itself. And so now I have an equation. Once you have that, we can use that to approximate this value. So all I'm going to do is plug in 1.1, and you get your answer. Okay? For part C, it says find a particular solution to the given differential equation with the initial condition. So what we're saying here, when f of 0 is -2, that's saying when x is 0, y is -2. Okay, our inputs and outputs. So what I'm going to do this time is I'm going to kind of review our separable equations. Okay, and we'll do more of these in a little bit. So I'm going to write down dy over dx is negative 2x over y. And what you're going to do is cross multiply so that we get our y's together and our x's together. And then we're going to take the integral. So I'm going to step over here and I'm going to do y dy equals negative 2x dx. Once you have that, I just did that from cross multiplying, I'm going to take the integral on both sides. And that's going to give me y squared over 2, negative 2x squared over 2. So my 2's will cancel, and then a plus c. What this information is going to do is going to help us figure out what that c is. So when y is negative 2 and x is 0, what's my c value? Should get 2. Once you have that value, we can plug it back in to this equation over here. So I'm going to clean this up a little bit by multiplying, just getting rid of this 2, okay, and putting it on the other side. So I'm going to get y squared equals negative 2x squared plus 4. Now, kind of skip some steps, so let me explain what I'm doing here. When I distributed that 2, it was 2c, and my c is 2, so that's how I'm getting 4. I'm just going to do some basic algebra here. I'm going to take the square root on both sides, write plus or minus 4 minus 2x squared. You don't have to flip those around. You can, it doesn't matter. Okay, let's talk about this plus or minus. Because our point is at 0, negative 2, we only need to worry about the negative part. So we can actually get rid of this positive and just keep the negative part of it. It's not really necessary to keep both the plus and the minus. Okay, so this would be our answer. All right, what I'm going to do now is I'm going to pause the video again, and I want you to try to work out these next few parts on your own. What I'm going to do is, you're going to work out number 2. What I'm going to do is fill it out, and then when I play it, I'll walk you through what I got, and we'll compare. Okay, so I made a chart for some of my values to show you where I'm getting these from. What's nice is when you plug in negative 1, you're going to get zeros all along here, so it doesn't matter what your y is. You're going to get some undefineds because you can't divide by 0 here. And you're getting some different slope values. So when you're plugging in 0 for x and 2 for y, I'm getting 1/2. So not as steep a slope as it would be when I plug in 1 and 1, giving me 2. So I tried to show that here. Sometimes it's kind of hard to show you know, a 1 slope versus a 2 slope. Just do the best you can. It should look something kind of like this. And mine's not perfect, but you get the idea. Okay, so this is where those values are coming from. That's part A. Part B is just like the last one on part B. So I'm setting up this right here, and I'm cross multiplying, and that gives me y dy, and then x plus 1 dx. I'm going to take the integral on both sides, and that gives me y squared over 2, and then x squared over 2 plus x plus c. I'm going to use this initial condition again to figure out what my c value is. C ends up being 2 once again. So I plug that in. Again, I'm trying to get y by itself, so I started by multiplying 2 on both sides. So what happens is that 2 is going to cancel here. You're going to get 2, and your 2 times c becomes 4. Then I take the square root. Once again, because my initial condition is a negative number, I did not do the plus or minus. Okay, so hopefully you feel confident about graphing slope fields. What I'd like to do is look at some more challenging separable equations. So the first one is actually not too bad. That's what we've been doing. So what I'd like you to do is actually just try that on your own and pause the video when you're ready to see them. Okay, so hopefully you got through number 1 with no issues. It's a lot like the other ones we've been doing. So I'm cross multiplying, taking the integral on both sides, Once I integrate, I'm just doing some algebra. I'm multiplying 2 on both sides, and I don't have an initial condition, so I'm keeping the plus or minus and taking the square root. Let's look at something that's a little different, like number 2, where it's just equal to y squared. We're going to do the same thing where we're cross-multiplying. Keep in mind that this is technically over 1, so you're going to get dy equals y squared dx. We want to have our y's together and our x's together. So what I'm going to do is divide both sides by y squared. I'm just going to write this so it looks a little bit more familiar as 1 over y squared dy. I always like to have my dy's off to the side. You could also just put it in place of 1. And then this is going to be 1 dx. Again, you don't have to put the 1, but I like to. Go ahead and integrate. So I'm going to bring this up to the top. So it'll be y squared, or y to the negative second. Add your 1, divide. That's going to be equal to negative 1 over y. Add your plus c here. Now what I want to do is I want that y to be up top, and I also want to get rid of this negative. So we're just going to kind of switch these around, and I can say that y is equal to 1 over negative x plus c. You could put this in parentheses, but because we don't know what c is, it really doesn't matter. So this would be my final answer. All right, let's look at a few more that are just a little bit different. Okay, hopefully on number 3, you're recognizing that both of these have a y. So what I'm going to do is actually factor that y out. Then I'm going to cross multiply. And I'm going to divide both sides by y so that I get rid of that. Once you're at that point, you shouldn't have any issues integrating this. So let's look at what our final answer will be. So the integral of 1 over y is actually ln y. Bringing back that old friend of ours. And then integrating the rest of this should be easy, just basic power rule stuff. Square minus x plus c. Okay, how we deal with it from there to get y by itself, you may remember from pre-calc that e and ln cancel each other out. So what I can do is raise, you can put an e on both sides and keep these as kind of like my powers, because what's going to happen is e to the ln y actually is y. And now nothing's going to really happen here. I'm going to have to keep that the same. But this is all in my power. I can use some algebra exponential rules because we've talked about this before. Whenever you're adding, that turns into multiplication. So I'm going to rewrite this as e to the x squared minus x times e to the c. And then I can just write this a little bit better because e to the c is, we don't know what c is. It's a number, okay? So e to the c is really no different than c. So I can rewrite this. You could leave it like that, but I think it looks a little bit better if you write it like this. And just in case if you're doing something multiple choice, you realize that these are equivalent. All right, let's have you try number 4 on your own and then play when you're ready to see the answer. And to get you started on number 4, I want to remind you that when you are subtracting in your experience, that's the same as division. So I would start with your problem looking like this. Okay, so here's number 4 worked out. So talked about separating that. We're going to cross multiply, keep the integral on both sides. What's happening here is a little reverse chain rule action. You can do u sub, but instead of multiplying by 2, you just multiply by 1/2. E to the x is just e to the x. What I'm going to do is I'm going to take ln on both sides, and that's why I put it in brackets. And ln to e to the 2y is just 2y. So I'm moving up here now. Then I can't really do anything with this, so I'm just going to take ln of 2e to the x. If you remember from pre-calc, you have multiplication here, so you can split that up to addition. And now I'm just going to do some algebra. I'm going to divide every single thing by 2. Now, you don't have to cut c in half because it's just c. We don't know what it is. And the reason this is